Lastly, we have the colligative properties. Basically, class, this colligative property is just a short presentation. So, I was supposed to do screen recording pero mahirap siya, no? I'm having a hard time kaya ganito lang yung gagawin ko. Just video it, no, from the laptop. So, basically, when we say colligative property, it is actually the physical property of solution that are affected by the number of particles. But hindi siya, it is not yung identity yun yung parts ng solutes. Okay? Hindi siya solutes but it is more on the number of particles. So basically as a one siya solution. So these are the physical properties. Okay? The word colligative means depending on the collection. Basically meron lang tayong 4 colligative properties. We have vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So we'll go through that later on. So before that, low class, no, the colligative property, this is just a property, no, that affects also the concentration or the property of the solution. So yeah, we'll go through in the detail in the next page. So let's proceed with the first one, the vapor pressure lowering. Kung makikita nyo sa picture, ganyan yung itsura niya, no? So that is on the vaporized state of the substance. The greater the number of solute particles in a solvent, the lower the resulting vapor pressure. What does it means? Kung mas marami dahil yung solute, mas mababa yung vapor pressure. So the tendency is that the vapor pressure is, when we say lowering the vapor pressure, we know but that vapor, these are gas particles now. These are gas particles that are somehow more less dense compared to those water, so it goes upward. So in this, by mere reading it, no, vapor pressure is the pressure exerted in a closed container by liquid particles that have escaped the liquid surface and enter the gaseous state. In a closed container at constant temperature and pressure, the solvent particles reach a state of dynamic equilibrium, escaping and re-entering liquid state at the same time. So kapag sinabi natin there's a state of equilibrium, yung ating container nababalance siya. Yung amount ng mga substance na nasa liquid state, rebalance sa amount ng mga vapor, no, na nagiging gas. So the experiment shows that the adding of the non-volatile solute, so non-volatile solute is one that has a little tendency to become a gas. So kailangan siya ng higher temperature. So kapag sinabi nating little tendency, it's very hard for it to be in a gaseous state. Okay? So it actually, yan. So a solvent lower the solvents, okay? The solvents lower the solvent's vapor pressure. So that is for the vapor pressure lowering. Para mababa natin yung vapor pressure lowering, so we have to actually have the balance, no, in terms of the solvent particles should reach the dynamic equilibrium. Ito na yung tatandaan nyo, class. Kapag vapor pressure lowering, the greater the number of the solute particles in a solvent, the lower the resulting vapor pressure. Yun lang. So let's proceed with the next one. The boiling point elevation naman. Ito naman yung tatandaan nyo. The greater the number of the solute, the particles in a solvent, the higher the boiling point. Okay? The greater, kung mas marami daw solute, mas mataas yung kanyang boiling point. Yan. The temperature at which a liquid boils turns into vapor is called the boiling point. Boiling point siya kapag yung mga liquid nagta-turn into vapor, yung ating liquid, no? Specifically, yung example natin sa water, yung water vapor. Kapag na-reach na yung point na yun, that's already the boiling point. A liquid in a pot of a stove boils when its vapor pressure equals to the atmospheric pressure. Yan. Sa experiment na to, yan, sa ating illustration also, yung liquid natin, okay, pag umamot na siya ng boiling point, nag-equal siya sa atmospheric pressure. Ano ba yung atmospheric pressure? Yung atmospheric pressure natin is the pressure that surrounds us in our surrounding. That's why lumalabas yung ating vapor, okay, going upward siya kasi mas less siya. So it equalizes to the to the pressure of the surrounding. Okay? So basically, yan yung tatanungin kapag boiling point elevation, the greater the number of solute particles in a solvent, the higher the boiling point. So parang directly proportional sila. Mas mataas, mas maraming mga solute, mas mataas yung kanyang boiling point. Yan. Let's proceed with the next one, freezing point, depression. Yan. The temperature, okay, ito yung tatandaan ninyo. The greater the number of solute particles in a solvent, the lower the freezing point. Okay, the greater the number of the solute particles in a solvent, the lower the freezing point. So basically, kabaliktaran lang ito siya class, no? Ng second statement. Sa first statement natin kanina, the higher the boiling point. Ito naman, the lower the freezing point. This is technically the ano uh, this one is for the boiling point elevation, directly proportional. For the freezing point depression, inversely proportional siya. Okay, when it comes to the relationship of the solvent and the freezing point. Solvent greater number, lowering of the freezing point. Yan. The temperature at which liquid turns into solid at an atmospheric pressure is called the freezing point. So basically, it freezes. No? Yung mga particles is the heat or the energy, the kinetic energy is turning into potential energy. No? So that's why hindi na siya nag-move yung mga microscopic or atomic particles niya. And the freezing point of a solution is always lower than the pure or not of the pure solvent. So let's proceed with the last one, osmotic pressure. Kapag osmotic pressure naman, ito yung tatandaan nyo. Osmotic pressure depends on the number of solute particles in a given volume of solution. So kapag osmotic pressure, yan, naka-depend siya sa kung ano yung amount ng part ng solute na nilagay sa solution. So basically, this one, the same lang siya class no sa concept ng osmosis sa cell. Kapag the more concentrated yung side, okay, pupunta siya sa less concentrated. So that's a difference in concentration gradient. No? So that's osmotic pressure. So again class, those are the four types of colligative properties. We have the vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Just take note of the examples, specific examples ng mga properties nito.